Hi, my name is Brianna Poon, and this is my lab report for Lab 1, Constant Velocity in Physics 2211. So the purpose of this lab is to analyze the motion of an object that is moving at the same speed without changing direction. And so to do this, I use the tracker software to digitally analyze the motion of an object through video, and I also created a computational model to theoretically represent the motion of the object. And then I compared my observed data from the tracker software with my predicted data from my computational model. So some fundamental principles in this lab are Newton's first law, which states that an object will keep moving as it is unless acted upon by another force, and Newton's second law, which states that the forces that are exerted on the system by the surroundings will change the acceleration of an object over time. In this case, we're estimating F net to be 0, so that means that the acceleration is also 0 and velocity is constant. So two formulas that we'll need here are the position update formula and the velocity update formula. Because we're estimating velocity to be constant, v average just equals v initial, and also F net is 0, so this portion of the velocity update formula will cancel out. So this just shows that velocity is constant. So my procedure involved analyzing a video of a rolling trolley through the tracker software. So the system in this case is the trolley, and the surroundings are everything else. And I used the data from tracker to calculate initial velocity, which I inputted to my code in GlowScript to create a computational model. And then the data from tracker and the data from my model were compared through a graph. So assumptions here are that net force equals 0, meaning that there's no air resistance or friction from the surroundings, and I'm only analyzing motion in one direction. So here's a video of my tracker analysis, and I chose this direction towards the right to be my positive x-axis, with the origin starting at the center of the trolley at time equals 0. So the initial conditions I gathered from the tracker data are that the position at time equals 0 is 0.0003 meters in the positive x direction, and velocity I calculated using this formula here and came out to be 0.2996 meters per second. And start time was 0 seconds and end time was 1 second, and the frame rate was 30 frames per second, meaning that each frame lasted 1/30th of a second. And I inputted that data into my code here. The system mass here doesn't actually matter because, again, F net equals 0 in this case, so it would just cancel out. And then I inputted my initial position here and velocity here, and delta t is the frame rate. And so here is the process of iteration that we're undergoing in the model. This is the velocity update formula. Again, F net equals 0, so this is just constant velocity. And because velocity is constant, this average velocity here is just the same as the initial velocity. Here is the graphical comparison of my tracker data represented by the blue line and my computational model data represented by the orange line. So initially, the velocities of both my observed and theoretical models are similar, which is expected because it is assumed that there is 0 net force and no effects from friction or air resistance on the movement of the trolley. But the velocities do begin to diverge at around 0.3 seconds, which shows that there is evidence of some outside force influencing the movement of my object. So some sources of error here are that the movement of my trolley isn't perfect. I use a trolley and the track with it to kind of minimize the effects of friction, but of course that's not perfect because there is still some effects from air resistance and such. And I also did film the video at a slight angle, which may have affected the position distances that I inputted in tracker. And so some questions for consideration. I chose my axes to be in the positive x direction in this case, but if I were to flip that and make that the negative x-axis instead, my position versus time graph would be downward sloping and velocity would be in the negative direction, but the same effects would still be observed because the magnitude of my position and magnitude of my velocity would still be the same. And is it possible to tell how many forces are added to give a 0 net force? No, in this case, because even though I tried to minimize the effects of any outside friction or air resistance through the trolley, there was still some acceleration or deceleration due to friction and air resistance, as shown in the graph of my observed model. That shows why it diverged slightly lower than my theoretical model in my compared graph. So that is the end of my lab presentation, and thank you for listening.